Hello everyone, and thank you for attending today's webinar, Gigabit++ with Wired and Wireless Convergence, sponsored by Sterlite Technologies. Before we begin, I wanted to cover a few housekeeping items. On the right-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget. Towards the end of today's presentation, we'll ask you for your feedback. A survey will pop open on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to our moderator, Heavy Reading's Principal Analyst, Sterling Perrin.
Hi, thank you, Becky, and hello everyone, and welcome to today's webinar. My name is Sterling Perrin, and I'm a Principal Analyst with Heavy Reading. I'll be the moderator for today. And very happy to introduce our guest speaker, Rajesh Gangadhar. He is Head of Wireless Broadband Converged Platforms with Sterlite Technologies. Rajesh, hi, welcome to today's webinar.
Yeah, thanks, Sterling. Hi, everyone. Thank you all for joining. Looking forward to it. Thanks.
Yeah, should be a good webinar today. So for everybody in the audience, the agenda should be up in front of you. The first bullet there, I'll give a little bit of a perspective on 5G status as well as getting into the topic of transport as it relates to 5G. And then Rajesh will really hit the next 3 of those bullets, the fixed wireless use cases, various fixed wireless options and requirements. He'll walk through really all the major options and how they relate to one another. Different considerations should be made, and then he'll wrap up with a little bit of a look at the converged network of the future, and then we'll open up for Q&A. For those who are familiar with our webinars, we always have a Q&A session at the end. We should have about 10 to 15 minutes, so please do ask those questions electronically as they come throughout, and we'll hit those at the end. We also have 2 poll questions, which will appear a couple different points through the webinar. So please look out for those as well. So it's just starting with the state of 5G today, and then getting a little bit into transport after that. But really, any 5G discussion needs to start with the state of the industry today on the radio side. The 5G new radio draft specs for the first phase were approved in December 2017. That was what's called 3GPP Release 15. And work on the second phase, which is 3GPP Release 16, is scheduled to be finalized by early 2020. Up until recently, that Release 16 date was end of 2019, so it did get pushed out a bit. So a little bit of delay, about 3 months or so, but early 2020 is the time frame they're giving now. Release 15 introduced the non-standalone, and this is in which the 5G radio shares the existing LTE 4G radio and core network, so it was a kind of a shared release. There was also a standalone implementation that was completed in July of last year, but really Release 16 is the full release of 5G NR. That's the one that's really going to bring the full spectrum of 5G use cases beyond really the enhanced, the greater data rates, moving into the ultra-reliable, ultra-low latency, and a lot of the IoT types of applications as well. So that Release 16 is the big one. The chart in front of you actually comes from test company Viavi. We've used this in another presentation. They were generous enough to let us source them here. State of 5G deployments Viavi. This was put out just before Mobile World Congress in February of this year, and it shows the state of commercial 5G through 2019. If you look through it, there's 13 commercial networks that were started by the end of last year, and that includes both fixed and mobile services. And by the end of 2019, which is the snapshot here, tallying them up, that's expected to be 55 commercial 5G networks. You can see it's a global picture. The U.S. as a country is leading the charge with 6 planned or existing networks by that time frame, but you can really see all through the world. Not just Asia, but also, although Europe is sometimes said to be lagging, there's actually quite a bit of activity going on throughout Europe as well. So Heavy Reading has recently completed a pretty large-scale study of 5G in partnership with 5G Americas. This was a network operator survey-based report, and that was also published in February of this year, just before Mobile World Congress. And we had 147 operators responded globally. And the report itself, you can see the source down there, is actually available for free, so you can look that up and get a lot of good data in that. A couple charts I'll show from that study. And this particular one that's up now, we asked operators when they expect to make their initial 5G launches, which is the red bar, and then when they expect to move to commercial mass market launches, which is the gray bar. You can see pretty consistent with what I just showed on the last slide. There's a lot of activity expected in the 2018 to 2020 time frame in terms of initial launches, about 69% of the survey group expecting to launch then. The mass market launches, though, will come a bit later. You can see the gray bar, about 60% in the 21-23 time frame. So this is where the industry expects to move to mass market. I'd say that from a transport perspective, the really important one for the industry to look at, and the one that I look at quite closely, is that mass market. This is the transport networks really need to be in place fully for that to happen. Initial commercial launches, you can do different things in small scale, but the wide scale is the big one. So this is what we're really looking to plan to 21-23 time frame. Another data point from that same survey. We asked operators, what will be your company's primary driver in deploying 5G networks? And we had 2 time frames here, within the next 2 years, which is the red bar, and then over the next 5 years, which is the gray bar. You can see an interesting development in these results as well. The near-term focus is clearly on faster speeds. You can see that first bar, red bar on the far left, getting the highest within the next 2 years, the greatest traction. So this is the enhanced mobile broadband types of applications, again, which kind of the types of things that are enabled by Release 15 as well. But the long-term driver, there's quite a big shift. If you look out over the next 5 years, it very much moves to really the Release 16 possibilities of 5G, new markets and new services, kind of the full spectrum of what 5G does. And so we're going to see, based on this and based on just our anecdotal data points that we gather, early focus on higher speeds, just getting 5G out there, but then really to move to the full potential over the next 5 years. Getting into the transport topic at a kind of broadly here, and then the next slide I'll delve into the topic of this webinar, which is the fixed wireless component to it. But at a very broad level, when we ask operators about what are their biggest transport network challenges as they move to 5G, these bullets really encapsulate the primary ones that we get, and maybe not necessarily in descending order, but that first one is definitely a big one that comes up in all cases in our discussions and surveys. Meeting the ultra-low latency requirements for 5G, again, that's part of the main Release 16 potential of 5G, and it's clearly an issue for the transport network to get there. But also with that, also very important is extending the wireline connectivity to new cell sites. So we know there's a lot of new cell sites that need to be built in order to both to increase the speeds as well as just to meet the application, the use cases of 5G, generally called densification. And this is a big challenge for the transport network because these are sites that are new, and from a network perspective, they're places where network generally does not exist in many of these cases. Meeting the capacity requirements is also important, so we know that 5G, the radio speeds go up, so that has implications, all through the network. Certainly for the what we call the X-haul, which is the front haul, mid haul, and backhaul. All of that needs to be upgraded to meet those radio data rates. Timing and synchronization is another big one. Different implications for different networks in different regions. A lot of challenges in synchronization when we get to front haul in particular, but again, this topic is not specific only to front haul. There's implications for timing and synchronization in front haul, mid haul, and backhaul as well. So all of that needs to be planned for. And then last but not least, although I don't think we'll hit on it too much today, the whole virtualization aspect of 5G with functions being able to move in different parts of the network is clearly an issue for network operators as well, and that has implications for transport. My last slide before I hand things over to Rajesh to dig into the fixed wireless, I did want to hit on the topic of fixed wireless initially just to underscore the point that it's an important aspect of transport. In that same survey that was published early this year, we did have a whole section on transport, and we asked a few questions about fiber versus wireless, and this was one of the questions we asked. And it's interesting, in the beginning, many people in the optical industry, and really I think broadly in telecom, thought that the entire front haul, mid haul, backhaul network for 5G was just going to require fiber connectivity. But in the survey, as this chart shows, when we asked the operators to identify the expected physical media mix for their coming 5G networks, so these are their planned networks, we got an interesting picture, which is, yes, fiber does dominate the expected transport network connectivity, with 63% in this survey question, but nearly a third are actually expecting wireless connectivity, not fiber, to meet those transport requirements. And so we see wireless is going to be a major contributor in areas where fiber just simply isn't available, which continues to exist in networks, or in places where it's just too expensive to make a business case for extending fiber. This picture is a little bit different from what you would see when we polled operators on what their existing networks are today, but not radically different. We're seeing an uptick in fiber for sure, but still a very strong and similar expectation for wireless connectivity. So the operators understand that they just can't put fiber everywhere for a number of reasons, and really that's going to be the focus of the rest of the webinar. And Rajesh will go into detail. So within wireless, that kind of reddish-orange piece of the pie there's a number of different options for what could be used, and Rajesh is going to go to a lot of detail on what those are and different considerations for planning that out. So with that, let me hand things over to Rajesh to take us through the remainder of the presentation. Rajesh, I'll let you take it from here.
Well, thanks, Sterling. Really appreciate that introduction. Hey, thanks again, all of you, for joining, and very good afternoon, good morning, and good evening to all of you. So what exactly do we mean by Gigabit++ with wired and wireless convergence? Beyond the catchy title, we truly believe that for 5G to succeed, there needs to be a real convergence of wired and wireless infrastructure to deliver gigabit connectivity and beyond to the network's edge. And to achieve this convergence, we are going to propose a cohesive approach to designing networks of tomorrow. And as I walk through the next several slides, I hope I'll be able to make the case for taking this holistic approach. So as Sterling alluded to, 5G is really, is bringing in a lot more than just mobile connectivity. It's, for the first time, 5G is going to bring in verticals that are going to integrate, industrial, healthcare, autonomous cars. So we really look at a global, connectivity, which will scale beyond what we've had before. And not just the applications themselves, but rather the amalgamation of all these applications will drive the need for gigabit connectivity at the edge. And, even though ultra-reliable, low latency applications are there, cumulatively, when you look at all of these applications, the edge network is going to require a gigabit or more connectivity. And that is the problem that we're hoping to address through this webinar. Now, we've had networks for a while. For a long while, we've done wired network infrastructure, dating back to the early last century, starting with, copper, and then slowly migrating to coax for cable TV, and then more recently, over the last maybe two and a half decades, fiber connectivity, more from an aggregation standpoint, not so much fiber to the edge. The recent push to 4G and beyond is definitely taking fiber beyond where it has been previously. Copper, of course, the DSL and ADSL technologies, they have limitations beyond a few megabits. Coax has a lot of potential. There's innovations in the DOCSIS standard that are taking it towards 10 gigabit, full duplex as well. So, but really, when you think about infrastructure growth, infrastructure that needs to be put in place for the real gigabit at the edge, fiber is the sort of the technology, the default technology for wired connectivity. And as these applications start to proliferate, Sterling mentioned EMBB, enhanced mobile broadband in the near term. Really, I think we look at the larger, it's a densification of the devices. It's the combination of sensors, smartphones, smart devices, and all the consumer electronics that are going to be connected to the networks that are going to drive density upwards of millions, if not billions, in the network. And that, in and of itself, is going to drive the need for us to have gigabit connectivity at the network endpoints. And to a consumer, it really shouldn't matter whether it's wired or wireless. The consumer really cares about the user experience and what value that the particular application brings to that user. And that's very clear with what we have seen, the data points that we have, even with 4G LTE, with all the streaming OTT applications that we see today. So really, I think from an endpoint and node, from a standpoint, 5G or 5G NR more specifically is the solution that will enable gigabit connectivity. But to bring that gigabit connectivity on the wireless access, there needs to be a robust transport layer, and for that we really believe that fiber is the sort of the de facto wired connectivity solution. And not only that, in order for us to have the density of devices that would require these types of bandwidth, we will need roughly 20 to 30x more small cells. And so combined together, it really means that every endpoint will technically require fiber. Now, all of us who've been in the industry know fully well how difficult it can be, how challenging it can be at times to get wired connectivity. Many a times there are terrain issues, ROW, right-of-way permitting issues that can lead to long delays, costs, expenses, and also just the logistics of getting fiber to a location just because of the number of miles that have to be covered. The time to market aspect is really critical at this point. So even though we believe fiber is the way to go, we, as Sterling pointed out, there are situations where you absolutely have to look at other alternatives. And that is the right business sense at that point to make a customer acquisition. Now, we just go back to our network where we had the wired infrastructure just to refresh our memory, but then really what we are saying is that we transform that network. If that network had the same impediments that I had previously shown, which is terrain or right-of-way or just other challenges in bringing fiber to that location, then fixed wireless is an excellent option to extend connectivity from where we have fiber today. And really at this point, we are looking at convergence of wired and wireless. It's not wired or wireless, but rather it's wired and wireless, again, for the transport layer. And just in the context of this presentation, I want to make sure I make it very clear that we are not just looking at backhaul, but also mid-haul and front haul. So when I say fixed wireless, it is sort of, it spans all of these hauls, maybe just call it X-haul for ease of understanding. And it really shows how nimble fixed wireless can be in providing gigabit connectivity at the edge. Now, fixed wireless has been around for a while. This is not a new topic. We've had licensed microwave backhaul for cell tower backhaul. We've had niche applications of fixed wireless to provide connectivity in rural communities. So fixed wireless really is not a new concept, but what it is, what is driving this new interest is really this whole, rather the density of deployment that will be required to provide gigabit connectivity everywhere, and the SLAs that come along with it. So just a quick overview of the use cases. By no means are these exhaustive, but rather just to give a flavor of what fixed wireless can do. Obviously, cell tower backhaul point-to-point connectivity is very a standard implementation. And we can also look at enterprise, rural access, high-density venues, hospitals, campuses, universities, and of course high-footfall areas as well. And again, use cases are really abound. So at this point, we are at the first poll question. Sterling, you want to take it away?
Yeah, thank you, and thanks for that introduction to the topic, Rajesh. So everybody should have up in front of you the first of the two poll questions. I'll read it out here and then give everybody a minute or so to pick their main option and submit. And then once we get to a critical mass of responses, I'll push out the results and everybody can see at least what this audience thinks. So the question is, which of these options do you think would be the predominant use case for fixed wireless last mile connectivity in your network? If you're a network operator, obviously answer on behalf of your own network. If you're a supplier into the industry, kind of maybe change that to just what do you think is going to be the most predominant fixed wireless connectivity just based on your experience with end customers. And so rural connectivity, Rajesh kind of went through these different options on the last slide. Rural connectivity, cell tower backhaul, small cell backhaul, enterprise connectivity, or homes, which could be either a single-family home or a multi-dwelling unit, depending on where geographically those are located. And let me just see how things are coming in. And when we get to it, we have a good number of attendees. So I'll also remind while we wait, we will have time for that Q&A at the end. So if you do have questions, please do ask those electronically. We have an interesting mix just kind of scanning through, definitely a global audience, so quite curious myself what we'll get for questions. Let me just push these out here, and maybe I'll do a refresh in a minute. But this is where the results are coming in so far. So interesting, about a third of the audience saying rural connectivity, and then second to that at about 23% small cell backhaul, and then actually quite close to that, the right to the home. Then it kind of drops off from there. If I do one last push, it just looks pretty similar. Yeah, Rajesh, any, I guess two questions maybe. One, any surprises here? And two, does this look very different from what you would expect for traditional use of fixed wireless in, say, 4G and earlier generation networks?
Yeah, so I think rural connectivity is something that we've seen in the past as well. There's been several deployment use cases there. But what I think is interesting is the small cell and homes. I'm quite pleased to see that there is need for connectivity because really I think bringing the gigabit connectivity to the edge is what it's all about. So small cell and homes, we are bringing the user close to that gigabit connectivity. A little bit of a surprise was the enterprise. I was hoping that would be a little higher, but it's great that there's a good distribution across all use cases. Nothing below, really below 10 as such. So.
Yep, Very interesting. Let me just do one last push, see if it changed. No, it looked like it held steady. Good. So with that, let's go on with the program, as they say. Go ahead.
Sure. So, we've looked at the convergence of the network. Then how does an operator make a decision on this? How does one implement this converged network? And as a first step, we obviously know what the optimal solution for wired connectivity is, which is fiber. But from a wireless perspective, it's not just one or two technologies, but there are several technologies, and you'll see that going forward. So we really have to make a decision, a conscious effort in finding the right solution for the right application or use case. We looked at about 5 or 6 earlier, but and each of those may have a specific technology that fits the specific geography or location that you're operating in. So as we move forward, I think you'll get a flavor of what I was referring to. So the next slide is really, it's kind of a busy slide, but we've tried to really represent the entire landscape of fixed wireless across all the spectrum bands. And where we are going to focus are the ones that are called out here. Sub-6 gigahertz, obviously sub-6 gigahertz is used for more than just fixed wireless. It's really where all the mobility networks operate. It's also where Wi-Fi operates. But the focus here is purely going to be for fixed wireless. And maybe specific bands which are around 450 megahertz, 900 megahertz, and also the unlicensed 5 gigahertz. And moving on to the next band, is the mid-millimeter wave, really between 6 gigahertz and 42 gigahertz. Again, the 6 to 42 gigahertz is not a new band. There's been a lot of interest in the last couple of years purely because of the 5G NR discussions. But that band has previously been used for fixed wireless and for licensed microwave backhaul. Especially 6 to 21 gigahertz has been used for licensed microwave backhaul, and 24, 28 are all these bands that have been used previously for proprietary point-to-point and point-to-multipoint fixed wireless solutions. We move to further right, we go to the higher millimeter wave bands, and here's where we really get into the millimeter wave space. The 60 gigahertz V band is of a lot of interest. It goes between 57 gigahertz to 71, so really 14 gigahertz. And you'll see that as you move from left to right, you'll see the bandwidth available become exponentially larger, and that really helps push that gigabit out to the end user. And with that, of course, comes certain challenges, which we will discuss. So the V band, 60 gigahertz, and then we have the 80 gigahertz, which is more between 71 to 86. It's generally referred to as E band. And moving further to the right, we have the infrared or near infrared. There's a few niche technologies that have been around, or at least one has been around for a while, which is the free space optics. At least for a couple of decades. But again, the push to get gigabit connectivity has really gotten some renewed interest in that space, and we'll delve into that a little bit later. And last but not the least, on the right is the visible light communications, which is a more recent phenomenon, maybe about 7 or 8 years ago, where Li-Fi was coined as a term, light fidelity, and it's really, if you want to look at visible light communications, it maps exactly to what Wi-Fi is, and how that does that, I'll walk through a little bit. So this kind of gives you a spectral overview, and I just forgot to mention Satcom. Really lingering behind all of this is a whole host of LEO, low Earth orbit satellite companies that are launching thousands of these mini and micro satellites, and the push is to really get wireless connectivity to every nook and corner of the Earth. So as we look at these technologies, it behooves us to at least have a framework on how to look at, not really evaluate and sort of compare the technology, but rather look at a framework that allows you to choose the best technology for that particular use case or application. And some of the key ones, you can obviously add some additional attributes, but here are the ones that we believed that would have the most impact. Cost, of course, the total cost of ownership is critical, and this includes spectrum acquisition, if any. It includes the equipment cost, operational cost, etc. Line of sight is something that's very critical. It becomes more critical as you go towards the right of the spectra, and that's something that you have to really look at whether that's available or not as you design these links. Availability of link or the uptime is a critical metric for any wireless network. Typically, networks are designed to 5 nines, and that is sort of the reference even for fiber. So really, that's the benchmark that we need to look at and compare whether these technologies come close to it, and if not, then what's the trade-off between them. And then, of course, the range, how far these technologies can support, what is the maximum link distance over which you can maintain a minimum throughput and link availability. And these are some of the levers that you can play with, change the distance to get higher throughput, maybe better uptime, etc. So then, of course, the regulatory regime, depending on where you are, your bands are probably either licensed, unlicensed, lightly licensed, or shared. Any of these. So you really have to look at what's available in your specific geography and then decide on what technologies best fit. And then interference susceptibility, as the name suggests, technologies, they can be interference susceptible or not. That's something that you have to look at. And then, of course, last but not the least, the throughput. Really, what is the link capacity or the yield of that link that you're going to really get from. So as we move along, we see, we've sort of applied this, the framework, which we call Clarity, by the way. I should have spelled it out. But really, I think if you look at this, 6 gigahertz, again, looking at it from the more unlicensed perspective, you see that you have some flexibility with, line of sight, where you can get near line of sight or non-line of sight deployments. Availability of the link is fairly high because at these bands you can get very good penetration and also across across buildings, refractions, etc. But of course, you also have to look at which band within the sub 6 gigahertz you're deploying, and as you go higher in that band, you get into attenuation due to foliage, etc. So these are some of the considerations that you have to take when you do the network design. And look at technologies. Range, you can go anywhere from less than 1 kilometer to maybe even more than 20 kilometers point to point. And regulatory regime, we are just looking at the unlicensed, so it really gives you, the flexibility to deploy these so long as the band is available in your geography. Interference susceptibility, because some of these technologies reuse the 5.8 or 5 gigahertz band, which is now traditionally used for Wi-Fi, you are susceptible to interference, and this really becomes a design issue. And how you design the link becomes very critical, especially in urban, suburban environment where Wi-Fi is prevalent. And the throughput, really, we can go anywhere between the multiple 100 megabits or to all the way up to 1 gigabit. And some of the attributes of the technologies are, adaptive modulation, MIMO. You have some of the benefits of these that give you the improvement in capacity. We move on to the mid-millimeter wave range, and here again we look at licensed microwave and 5G NR. And licensed microwave, of course, again has a cost associated with it because you have to acquire the license. There is an OPEX there. 5G NR, again, we believe that it's the cost is primarily associated with spectrum acquisition. If you have a legacy network, that's relatively less, but if it's a greenfield network, you have to incur additional expense to deploy that network and actually stand up an LTE or 5G core. So that's really the cost element there. Line of sight is absolutely critical at these bands. As you go towards millimeter wave, point-to-point communication, clear line of sight becomes critical because the wavelengths of these bands are such that it actually gets absorbed or reflected by anything from foliage or perhaps buildings, etc. So it's really line of sight. What you see is what you get, and that's sort of bearing out in some of the early deployments that we've seen. Availability of the link is really, again, it's a metric that we see from a from the licensed microwave backhaul perspective. And what it really amounts to is how much downtime over a period of 1 year can you really support? And it's roughly about 30 minutes is what this comes out to be. And the range is anywhere between, again, 400 meters, where you really have to, for the 5G in our case, it's a fixed last mile access, versus licensed microwave that goes up to 20 kilometers. And I'll just move a little faster here because I'm told that we're running a bit behind. But I think it just gives you a flavor of what this Clarity framework can do. One quick point about V-band is that really I think one of the things about V-band is it's a short-range communication. It's affected by oxygen absorption and rain absorption, and it's actually the highest at this band. So that really limits the range to which these signals can go, and so that needs to be considered, in your design. But on the flip side, it also gives you a lot of spectrum to use, and and also the cost is relatively lower, only because the solutions are able to leverage the 802.11ad framework and then modify it to fit the point-to-point communication. And with the advent of 802.11ay, which sort of gives you the aggregation of multiple AD channels, you can actually drive up the capacity up to 10 gigabits. And really at this band, the important thing to understand is, because of the short range and the effect of absorption, oxygen absorption, you really have to look at a mesh topology, and we'll discuss that a bit later. Moving on to the E-band, this is also susceptible to rain attenuation, but not as much as the V-band, so you can actually get a little bit more out of this. Again, there's plenty of bandwidth here, and you can actually use 2 gigahertz, almost 2 gigahertz channels to drive up the capacities. Line of sight is critical at this point. That goes without saying for any of these technologies that are coming. And throughput, what we see currently is about 10 gigabit, but again, with massive MIMO and some of the other innovations that are happening, including channel aggregation, you can drive it up to almost 30 or 40 gigabit in the future. The next technology that we look at, as I said, is sort of getting a renewed interest here, really looking at free space optics, which is nothing but laser beams pointing between two fixed locations, and the technology sort of maps what's actually in the fiber optic cable. It's essentially the same principle. In fact, the wavelength that's used is also exactly the same. It's 1550 nanometer. It has its own advantages in terms of range and the ability to handle some of the atmospheric limitations. And one other thing is that 1550 nanometer also puts it in the class 1M laser category, which is eye safe. Unless you look into the beam with a magnified optics, it's actually quite safe for the eye. Because the cornea and the lens do absorb it. So that's a very key element here, because laser can sort of conjure up images of a lot of health issues. So it really needs to be brought out here. And again, we're looking at micro radian beam width, and it's really, unless you're right in the face of it, you're not going to even see the beam. Real quick overview here. FSO has its limitations. While it has a lot of advantage, there's gigahertz, in fact, terahertz of spectrum. You can actually get a lot of bandwidth out of it. It is also susceptible to atmospheric scintillations, fog, dust storm, etc. So it kind of puts the availability at a lower at a disadvantage, but then you can also design the network such that you actually compensate for that by modifying the distance or the throughput required. So it's as I said, you have levers to play with to adjust, and also useful use cases where you absolutely have nothing else, but and in fact you have no spectrum. One of the key advantages of FSO is that it's unregulated and it's free spectrum, so you absolutely have no limitation on how you can use it or where you can use it. So that's really a huge plus in this case. Again, a line of sight technology. Sorry, I'm pushing a little harder here, but just want to get to the end and really focus there as well. Again, visible light communication, as I said, it really is any LED can transform to a Wi-Fi source with a slight modification, and just modifying the current in the LED at a very high rate changes. You can actually use that to transmit data. So it's a very innovative technology. It has a lot of potential for in-home and enterprise and consumer lighting applications, but we also have looked at it for point-to-point communication, and any light source that a street lamp, for example, can be used for as a Wi-Fi source, and you can really look at this as a mesh of Wi-Fi which can cover the entire streetscape, so to speak, and really a great potential for bringing connectivity to the edge. Again, real quick, it is nascent technology. It is just evolving, so there's standards process going on. But we see a lot of potential upside to this in the long term. Right now, we see this as a short-range communication. Again, unlicensed. Visible light is unlicensed. And you absolutely don't have to have the light source on in order for it to function. You can use wavelengths that are not visible to the eye and still be able to get the connectivity. And at this point, we're seeing anywhere between 200 megabits to about a gig with some of the innovations. The good thing about this technology is you can pretty much use massive MIMO and meshing and all of those capabilities that we discussed previously. Not to miss out on some of the innovations that are happening in space. Really, LEOs have come back, or rather satellite communication has come back with a vengeance. We see a lot of interest here. More recently, we've had announcements from Amazon, but before that, OneWeb, SpaceX, we see a constellation, many satellites being launched. And the whole idea here is that you will have pretty much blanket the entire Earth with coverage, and anywhere from backhaul to direct access to devices can be served through these means. The advantage of LEO, it's much closer to the Earth. It's anywhere between 150 kilometers to 2,000 kilometers, and what that does is reduces the latency to between 30 to 50 milliseconds, and that's very much in the range of LTE at this point. And some of the other innovations to improve the latency are being looked at this point. So that's really something that we've also started to look at with great interest. And while the transponder capacities can go up to a terabit, we're really focusing on individual links, and that can be anywhere multiples of megabits to 1 gigabit. Okay, so we're here, Sterling, at the second poll question, so I'll just hand it over to you.
Okay, great. Yeah, thank you for going through all those options, Rajesh. Definitely very interesting level of depth on all that. So let's get this question, and then we'll move into the final piece of the presentation. So which of these technologies do you think have the potential for greater adoption in the next few years? So Rajesh obviously went through all of them, so you've got a little bit of insights from that presentation if you weren't familiar, but they're all listed here. Sub-6 gigahertz, mid-band millimeter wave, the V-band identified as the 60 gigahertz, the E-band, which is the 80 gigahertz, free space optics, Wi-Fi, which was the visible light, and then satellite communications. And again, we'll see if we can get to some sort of a critical mass here, and I'll push them out in just 1 second. We did get a lot of great questions in, so I definitely want to save some time for that. So may not be the absolute final say on this, but let's push out with this. Mid-band millimeter wave, 36%, followed by the sub-6 gigahertz, and then kind of falls out quite a bit. A lot of those newer or less familiar options not really resonating too well with this audience. Again, any thoughts there, Rajesh? Is this how you expected?
Very much so, especially FSO and Wi-Fi. It is fairly new and perhaps not as familiar as the other ones. Sub-6 gigahertz has been around for a while. Mid-millimeter wave, there's absolutely a lot of interest there, so I'm not surprised there at all. We and E-bands, again, depending on where you are in the world, that's again, the spectrum is either available or not at this point. So India being an example where that's not become available as yet. So this is great. Really good to see that at least there's interest in new technologies. So that's good to know.
Sure, and it may change in a year. I think it's a good poll question.
That's right.
Going. Great. So let's continue through here.
Sure. Great. So we've looked at some of the technologies. Now, how do we build that, converged network? And so, just to refresh the fixed wireless technologies, these are there's many, and there are also topologies that can be deployed. Various topologies that can be deployed. It can be point-to-point. It can be linear. It can be a star or ring, depending on whether you need a redundancy or not. And then mesh, of course, certain technologies always work better in that situation where you can actually communicate between links simply because of other impediments that might be there. So those are some other technologies, and how you apply them to the use cases is again, it's a design issue and it's a use case issue. So you really have to look at the overall network topology and see what works best, and also the region of the world where you are, whether it's a high rain rate, whether you have snow, whether you have fog. All these are the weather-related elements have to be considered when you design these networks. So how do we go beyond this, right? I mean, we understand the topology, we understand how these apply to the use cases. What we thought is it would be good to introduce this concept of integrated design. And again, we are moving towards this converged network concept. So what does an integrated network design mean? It really means that we look at all layers, whether it is fiber, whether it is wireless. We look at the layers of whether it's application layer, a logical layer, or physical layer. We look at all of them and then design the network while including all of them. Centralized planning is something that we think is very useful when you're doing a greenfield rollout, or even perhaps converting a network from what it is today to 5G ready, to look at the entire network holistically and plan both the wired and wireless infrastructure at the get-go, and then of course fine-tune it at a local level because of course you have the local issues that you have to handle. But from a planning perspective for capital acquisition and investment, I think it really makes sense to do that. The one converged network design is, again, looking at both the wired and wireless networks cohesively and looking at a unified network design approach. Reusing existing infrastructure, it makes complete sense. Why would you want to do any other way? And of course, surveying everything both for wired and wireless infrastructure saves time. It also saves money. So really, we are presenting this I-Core as a framework to do this unified converged network topology design. So how will a converged network look like, and the design look like? So you may have this fiber ring and a spur, and followed by, a whole bunch of wireless connectivity. And again, this is just an example. It's a representation. It's an illustration. By no means is a prescription. So, but it really, what we wanted to highlight is that even though the wireless technologies have impediments, some limitations, but combining some of these technologies, you can actually get both, best of both worlds. So for example, let's take, E-band and sub-6 gigahertz. Well, you have very high rain rate regions where you can still leverage E-band capacity, but where it fails or where it derates, you can actually start to leverage the sub-6 gigahertz bandwidth. So you're not completely losing the link, but at least having some basic connectivity. Similarly, we can think about FSO and E-band, right? I mean, you can combine the two, where FSO works really well on a clear day, whereas on a foggy day, you can still get E-band connectivity, but on a rainy day, FSO will still work, right? So you really can combine these two technologies and get the best of both worlds and get the higher link availability. And what we've shown here is how you extend that coverage to the edge and choose technologies that best fit the particular use case. And okay, so there you go. So, again, what will a converged network look like? I mean, we talked about wired infrastructure, we talked about wireless infrastructure for transport, and that includes the backhaul, mid-haul, and front haul. Where we think the network will go in the future is more than just the transport, of course, and the 5G NR access layer, but also aggregation of some of the other capabilities such as centralized or cloud RAN and network intelligence that will really look at unified platforms for managing all of these networks. It will be humanly impossible to manage these networks, in a multi-radio access technology network especially. And as we look at the 5G standalone, we look at network slicing and some of the other capabilities, but also multi-access edge compute, which will bring both storage and compute to the edge. Also, virtualization is another key component. We're looking at virtualization at the optical layer, at the radio layer, and also open RAN architectures. There's a lot of initiatives. So we're looking at a combination of all of these that will, sort of collaborate, cohabitate, and coexist in a world where everything that we look and feel and touch will be connected one way or the other. So how are we preparing at Sterlite Technologies? Well, our background has been in fiber and fiber optic cable manufacturing, but over the years we are also transitioning and evolving to a technology solutions provider. We've also taken our ability to build networks, especially the fiber networks, to actually increase our competencies to improve or build converged networks of both wired and wireless infrastructure. And in parallel, we are also developing software products that bring network intelligence, the unified management systems, and also AI to really automate all of the optimization and network configurations that need to happen almost dynamically, and also not to miss out on the fact that with programmable networks, we're actually really making our wired and wireless infrastructure open architecture and open RAN based. So really, we are actually preparing ourselves for this network of tomorrow, and we would love to partner and engage in further discussions with all of you and how we can help you achieve that goal. And we would love to hear from you beyond this webinar. We have a few social media handles. Please feel free to respond with questions, feedback, both positive and critical. We're happy to take that. So with that, Sterling, I'll hand it over to you for the Q&A session.
Yeah, excellent. Thank you, Rajesh. Great job going through a lot of material, by the way, and really interesting.
Thank you.
Let's jump right into it. So interesting. So question on low Earth, and we got a lot of questions in, by the way. We won't get to all of them. Do you see low orbit satellite-based connectivity for rural and less densely populated areas as part of the solution mix? I know it scored low on that poll question, but I'm curious, and this questioner is curious where you see the role.
Yeah, it's a very valid question because in the past, the interest has always been for rural connectivity and also for connectivity over water. But if you look at the whole idea or the rationale for low Earth orbit, it's really to blanket the entire planet with spot beams and other coverage, and I think that really lends to not just rural connectivity but also backhaul offload for urban and suburban environments. So what we see is that there will be situations where operators may be able to leverage excess capacity. Maybe it's only a few hours a day when you really need it, but then again, look at the satellite for excess capacity offload. So we really see the use case with LEO for both across all the morphological deployments.
Okay, excellent. And then this question I'll read it, but we may need some clarification unless, Rajesh, you know exactly what was being referenced. The question was, is it cost effective and how long will it take to reach India, or is it already available in India? So a question about India, but I don't know exactly the timing of what you were talking about at that time. I don't know if you recall offhand when this came in, or we can ask them to clarify which exact question they have.
Yeah, I would need a little bit more. I mean, if the question is whether these technologies are available in India, my quick answer is yes, sub-6 gigahertz we can deploy today. The E and V bands are not available today. They're still not been released by the government, so that's something that's not available. But free space optics and Wi-Fi, as I said, I mean, again, that's unlicensed and that's available as well. And mid-millimeter wave, just to cover that off, today you can use that for licensed microwave backhaul, but for really 5G NR, the auctions are scheduled for sometime late next year, or this year, or early next year. Yeah. Okay,
it might have been the government release that was specific then. Good. Let's see. Yeah, a couple. This is a good one. I think it touches on some of my questions as well. And I know there's a lot of options, so you may need to break down. But just generally, since fixed wireless solutions have lower link availability compared to fiber, certainly, are networks of the future going to be less reliable? So just addressing that reliability question in a little bit more detail.
Yeah. No, great. It's a valid question, of course. Those of us who've used wireless networks, we understand that link availability can always be a challenge, and it's the true nature of the beast. So where you absolutely critically need connectivity, fiber is the best way to go. But if you cannot get fiber, or perhaps you have a lead time that requires connectivity for perhaps, say, business, for customer acquisition. So for a business, from a business sense, you want to acquire customers early enough. You may want to do fixed wireless. Now, going back to the link availability question, you can actually look at, and I kind of touched upon that, where you look at multiple technologies that can sort of coexist and collaborate and give the best of both worlds, and thereby increasing the link reliability. So I think, again, just to put things in perspective, when we talk about 5 nines, in the wired infrastructure, we're looking at about a 5-minute downtime in the whole year. But if you go down to 99.995, that's about 30 minutes of downtime the whole year. Just for reference, if you look at 98.5 link availability, it's about 5 days of downtime, and 95.5% availability is about roughly about 15, 16 days downtime. So the question you ask yourself is, can you live with that downtime? And that may happen all at once or across a period of 6 to 7 months, right, depending on when the weather changes. So it's really, those are questions that you have to ask, and it's very, very critical to look at it from a local perspective, because these weather patterns are very unique to the local geography. So I hope that answers the question at least, somewhat.
Yeah, good job. So maybe just a quick follow-on to that, because it feeds into another question. And so the question that was asked, which you may not be able to address directly, was about mass market availability of ultra-reliable and ultra-low latency communications. I don't know if you want to touch that, but if the related question I was thinking here was, for ultra-reliability and ultra-low latency, are any of those options on the wireless side going to be viable, do you think? Or do you think when you get into those use cases, then that's the role of fiber absolutely and no other options?
Yeah, great question again. I think when you look at ultra-reliable, low-latency applications, you're really looking at tactile internet, AR, VR type applications. So again, this is more of an engineering design question. A lot of these technologies that I just referenced have a millisecond or lower latency point to point. So, you have to look at the latency aggregate between your, where your cloud is and your edge application. And that is where MEC plays a big role, multi-access edge compute. So if you really must bring that low latency to the edge, you may want to pick a location where you can actually bring MEC to the edge. So it's really, that's why I said, although we talked about the transport layer, it's really the converged network of tomorrow is more than just that. It's all of this coming together and bringing a cohesive, converged platform for all of us to leverage. So.
Good points, and good points on the multi-access edge compute. I was thinking that as well. For the latency, that becomes a absolutely critical piece that needs to come in. So for the audience, there should be a survey up. If you can just take a moment before we close out to take that survey and give us your feedback. And in the meantime, I think this will be our last question because we're at the top of the hour. So we'll close out with this one, Rajesh, and it is, even though fixed wireless solutions may overcome deployment impediments, they would still require power source and mounting assets that provide clear line of sight. And the question part of that is, wouldn't that pose challenge in rolling out fixed wireless? So how would you address that concern?
Yeah, absolutely. So, and this goes back to the point about surveying and looking at what assets you have. Leveraging existing towers, light poles, pick an asset that you want and look at leveraging that. So the one important aspect of this is getting enough height on these to clear the clutter, so you have line of sight, especially for the millimeter wave and the higher band technologies. So it's a tough choice. Again, that's where the survey comes in, and you survey everything that's around to be able to provide that capability.
All right, and with that, actually, let me just make one final point, because there were some questions about referencing the slides. You do have, for the audience, you do have access to the slides. You can download them from the console. If not, we can certainly get them to you post-show, but you do have them for reference. So with that, let's close out here. I want to thank everyone for tuning in today, and of course, thank you, Rajesh and Sterlite, for sponsoring today's webinar. So have a great day, everyone.
All right. Thank you very much. It was a pleasure. Take care.